Hey students, and welcome back to the Python for Machine Learning series. And today we'll be working on unsupervised learning. So this is the first time we look at unsupervised learning. So unlike supervised learning, unsupervised learning try to uncover structure. So what it means is that you're not provided with any targets or basically the why, but you're trying to uncover any structures, right? And clustering is one type of unsupervised learning, trying to uncover any significant regions of clusters, right? And k-means clustering is one of the most classic algorithm for clustering, right? So let's take a look. It's fairly easy. So for example, let's say that we have a data that's look like this, and let's assume that we have a 2D features, right? So we have one feature could be the weight, and this could be the height, or it can be anything, right? So assume as you please. So now by eyeballing, you can see that there are actually 4 clusters, right? And this is just prepared for demonstration, right? But anyway, as an algorithm, how do we let the algorithm know that there's actually 4 clusters? Well, firstly, you need to define some parameters called k, right? And this is something you have to decide by yourself. And a lot of people ask me, what is a k, right? There's no way, right? You have to identify by yourself. So that is one of the limitation of k-means clustering. So let's say you predefine that the k is 4. So once you define 4, you just initialize 4 centroids. We call the centroids randomly, right? It can be anywhere in this 2D map, right? And then what do you do? Firstly, you do something called E step, right? Which is called expectation step. So what do you do is, you assign each of the sample, the colors, to the nearest centroid, right? So for example, all the samples are nearest to this centroid, so they belong to blue, and all these samples is nearest to the green, so you say that they are green, right? And then what do you do after the expectation step? You do something called maximization step, right? In which you move the centroid to the mean of this samples, right? So here you got these blue samples that are nearest to the blue, then you move the blue to the mean. That is the center of this, and then you repeat, right? You once again do the expectation steps, assigning the color of each of the sample to the nearest centroid. So you can see that some sample actually change the colors, right? And then you repeat M again and repeat E again, M again. When do you stop? You stop when no samples change the cluster, right? The associated cluster. Then you say that this is completed, and you can say that now any samples associated with this centroid is belong to this cluster, right? So this is the idea of k-means clustering, right? And you can easily remember what is k-mean, right? K means that you have to define how many k, and the mean just define that you basically repeating this estimating which cluster it should be, go to the mean, estimating, go to the mean, estimating, go to the mean, and finally, when nothing changes, you call this the final cluster, right? Hence this name k-means. All right, great. So hopefully you understand this algorithm, and now maybe once we code a little bit, maybe we can gain a better understanding what is k-mean clustering. Great. So let's start. So we're going to do something called sklearn dot matrix import pairwise distance argmin. All right. And the first thing I want to show you is this function, right? This pairwise distance argmin, which is very useful if we want to do this algorithm by hand. So for example, I have x equal to np.array. Let's say in this array, we have 2, 3, and 1, 2. This could be the XY coordinates, X, 6, 7, right? And we have centers equal to np.array and 1, 1 and 2, 2 and 3, 3, right? So what I'm currently having, well, I have X, which is the gray samples, and I have the centers, which are the three circles. You can imagine I have three circles here, right? So what I want to do in the E step, so what I want to do is making sure that all the samples to the nearest centroid will belong to that center, right? So I have to find some function, right? So if you eyeballing, this one is near to center. This sample is near to center 1, right? Close to center 1, right? And this one is more close to 0, and this one is probably closer to 2, right? So we want a function that can return this one for us, so that we can color them accordingly, right? So I just want to show you that is that we can just simply use this function, and this is gonna do all the magic for us. So we just need to provide X and centers, and then this would give us okay, I did not import anything, so give me 1 second. All right. So you can see that it perfectly give you 1, 0, 2, right? So I just want to introduce this function, so later on you don't get confused. Why do I actually use this function? Great. So let us start right away from implementing, right? So from sklearn.datasets, we're gonna just use something called make blobs, and of course we're gonna get this, and we're gonna do this time. And we're gonna say that xy true equal to make blobs in samples. Centers equal to 4. And cluster, let's say cluster STD is like, okay, they are not so close together. And then random state is, you can put whatever random. You can try to plot this, but this is this, right? And please, one thing I wanted you to take note is that we're not going to use this thing called y true, right? Even though we know the targets, we want to make sure that our clustering algorithm can input just with the X, and it can predict the relevant clusters, right? And then maybe we can compare with y true, right? And I just want to make sure that you understand that in unsupervised learning, there's no training, right? You cannot train the algorithm because you don't really have the why, right? So mostly unsupervised learning is a series of iterations to find patterns, right? So for example, this is a series, so you don't really try to find any patterns using the y, right? You may mainly just use the x, right? So that is something I have to remind. Okay, great. So now we can define the algorithm accordingly, right? So we're going to call this algorithm k-means, and what this takens is just x and k, right? As the definition of this algorithm, what they input is just the input and the k, right? So this is a similar like that. And what do we want is that we want to return the centers, right? So this is what we want this algorithm to give us, right? Great. So how do we do this? First of all, maybe the first thing we can do is n equal to x dot shape, and we can now do something called randomly choose n clusters, maybe k clusters from x. So here, if I define the k to be 4, I can simply randomly choose any x to be a cluster, right? So, and those x won't, so basically I just copy the same coordinates and call them center, right? So that is another way you can randomly initialize. It doesn't really matter you initialize randomly 0, 0, 0 or from the x, right? But from the x, there's a one advantage that because it's right on the X, there's an easier way. It guarantees that you are right very close to all the samples coordinates, right? Great. So we can say that img equal to np.random state, let's say 42, and I equal to ing dot permutation. So we want to permute and find one number from this M, and we want how many numbers? We want k of them. All right. And we can say that centers is equal to xi. All right. So for example, what this was going to give me, maybe something like 52, 23, and 109, something like that, right? If my k is 3, right? And then centers is just a list of all this x, right? So that could be idea. Great. And of course, we can now number 2, what do we want to do is assign labels. So basically, these are E steps, right? Assign labels to the nearest centers. All right. So firstly, we can say that iteration equal to 0, and then we can say y true. Labels equal to pairwise distant argmin x centers. So this is super handy. And then what we can do is so that is the labels, and then we can see that new centers equal to that, and we can say that for I in range k. So for each of the cluster, we can say that new centers dot append x labels equal to I dot mean axis equal to 0, right? So there's a little bit of Python code. It may feels difficult, but the idea is that once we know that what each sample belongs to, we just make sure that okay, if the labels is equal to 0, then take the mean. Then I got the first center. Then when the k is 1, you got 1 here. Then you got another center for 1, right? And then and then so on, right? So that is the whole idea behind this. I think I should not have that. Then I can get, yep, I think that is correct. Yep. All right. And then of course, let's convert less to NP array just so that we can do more operations on top of that. So we can say new centers equal to np.array new centers. Okay, so later on we will need this to make sure is an array, but anyway, that should do it. What we can do is we call compute total within variation score. So what do you mean by within variation score? Well, how the first thing is how do we define that the cluster is good, right? Well, if the cluster is closer to one another, then that is a good cluster, right? But when the cluster is very like scattered around, very big, then that is not really a good cluster, right? So within cluster score is basically you compute the distance between each of the sample with the center. If it's very low, then it's good, right? So that is the whole idea of within total within variation score, right? And in fact, is we just say that firstly we're going to have this total with within variation score very long. You don't really need to have this long. You can have that TWVS, just up to you. Labels equal to pairwise argmin x comma centers. All right, and then what do we do here? And then what we can do is that for I in range K, cluster mean equal to X label equal to I dot mean axis equal to 0. Total regression score is plus equal to X labels equal to I minus cluster mean squared to make sure that it doesn't really matter is negative or positive, as long as close is okay. Dot sum. All right. So what we do is we make sure that we get the assigning labels correctly here. Actually, we don't really need to do this, right? I assume that this labels is already there, but you can optimize later, and then you can get the cluster mean, right? And based on that, you can compute the cluster mean, how far from each label from X, each of the X with this cluster mean, right? All right. Now we can of course print this total with variation score, and that is a total within variation score. Okay, great. So now, of course, we can also do some plotting, right? So we can see how things change every iterations. So we can do that for iteration mod 5, let's say, equal to 0. We can say that the prediction is nothing but the pairwise of the argmin of X in the new centers. So now we update the prediction, and then plt dot figure. Okay, let me save my time and just because I already prepared this. Okay, so this is just a figure size iteration, plotting the samples, right? And then the color is basically related to the prediction. So we now can see how does it update the clusters, right? And then of course we also print the clusters, right? Okay, so with the code is fairly easy. Now the last thing is that we don't want to do this repeatedly, right? So what it does is get the new centers, right? And then do it again, right? So we want to make sure that this stops somehow, right? So what we can do is we can say that if np.allClose centers and new centers, so we can see that okay, the previous centers doesn't really change. We just break the otherwise. This is very important, right? Centers equal to the new centers, and then iteration plus equal to 1. Okay, so if everything else is okay, then we break. Otherwise, the current center will basically equal to the new center, and then this is gonna loop again, and then this new centers will be here, and then you just do M, right, etc. Okay, great. So I think if I'm not wrong, that should be it. Maybe it's good to print that it's done, and iteration. Which iteration? Iterations. All right. Give me 1 second. Okay, I think that is the iteration. Great. So I think I did not do anything wrong, hopefully. And I will also create a function called predict. And how do we predict? Well, given the new centers that we find, assuming this centers is optimal, what we want is just a pairwise argmin, right? Which is a very handy function. And this center, this X could be any X, right? It could be X test. It could be some news data that you came in, right? And you just get the clusters, right? Great. Now we can actually try our algorithm. and hopefully things will be okay, right? So now we have X, right? So this is our X, right? So we have 1,500 samples, and so let's start this. So we're gonna do predicts equal to predict X K means X and K equal to 4. All right. So what do I do here? So this one will be running this algorithm, right? And this will return me centers, right? Just plug the centers right here, and then predict, right? Well, I should not do this, right? I should just do centers equal to K means and X K equal to 4, right? Great. So so we get the centers here, right? So you can see that in the first iteration it looks like this, and then in iteration 5 things are moving, iteration 10 is moving, and definitely is it ends and it's done in 14 iterations, right? So things looks good. Great. Now we can actually predict, and to predict we just say that the predicts is nothing but predict equal to X and the centers, right? I think I call the centers, right? Yeah, centers. And so that would be that. And what we can do is a PLT dot figure, and we can say that PLT dot scattered X, the first feature and the second feature. Yeah, this is just for plotting. And the C is equal to predicts, and S equal to 50 for the size. And I think that should be it. Right. So you can see that once we input some X, we can get which cluster they belong to, right? Great. So hopefully you understand this, and it's fairly a very powerful algorithm. And hopefully we can and there's a lot of use case in K-means clustering, right? One is customer segmentation, in which before you understanding any in finance, in insurance, there's a lot of applications, right? In understanding how your customer are segmented before you drill down to supervised learning, right? So great. Thank you very much, and see you in the next tutorial. Bye-bye.